Welcome to this GCSE Maths 2026 Higher Paper 1 Key Skills and Topics Revision video. What this aims to do is cover kind of all of the key topics that potentially will come up on your Paper 1 in GCSE Maths. Now this is quite a long video, it's a little over 2 hours, which is quite difficult to sit through in one sitting. However, what you might want to do is just pick out some key sections, fast forward through it, or listen to it at double speed or 1.5 times speed, and you can cut down some of the time. But again, if you just skip forward kind of 10 seconds, you might go, okay, that's a topic I want to revise. So you don't have to watch the whole thing in its entirety, you can just pick out the key things. Hope you enjoy it, and at the very end there's some kind of key tips to help you maximize your marks in your exams.
Quick disclaimer before we get started. Obviously these topics are ones that come up very regularly on one of the 3 GCSE Maths papers. Obviously we can't guarantee that all of these topics will come up on paper 1 or any specific topic will be on paper 1. There are some things like surds, etc. that can only appear on paper 1, but for the most part these questions could be on paper 1, but equally they could appear on paper 2 and 3 and may not be part of your paper 1 exam. But again, this video is to encourage you to be part of your revision along of all the other stuff that you're going to do, including some practice papers, etc. The first topic we're going to look at is rounding, and rounding obviously can form part of any paper, but it tends to be that last mark on questions, and we just want to make sure that you don't get that wrong. So it says round 107.197 to 1 decimal place. So looking at that first decimal place, the number after that is a 9, which means it's closer to the next value, so you should have got 705.2. Equally, looking to 2 decimal places, again that's 2 numbers after the decimal point, we're looking at this 9. Now this 7 is going to round this 9 up, and in cases like this we do something called double rounding, where this 7 rounds this 9 becomes a 10, which means you have to carry the 1. So we end up with 705.20. We must include that 0 because it's asked for 2 decimal places, so our answer must finish with 2 decimal places. Now, significant figures are slightly different. Significant figures are the first non-zero digit that appears. So in this case, our first significant figure is the 7. So essentially what we're doing is we're rounding this number to the nearest 100, which in this case would just be 700. Equally with 2 significant figures, we're looking at the first 2 zeros. Now, as I said, non-zero digits. Once you find the first significant figure, every consecutive digit after that is a significant figure. So those are both significant figures, the 7 and the 0. So rounding that then, that's 705, which again is closer, we're rounding to the nearest 10, so that's closer to 710 to 2 significant figures. The final one asks us to truncate to 1 decimal place. Now to truncate simply just means to cut. So we go to 1 decimal place, we cut, and then we just ignore this number afterwards. So when we ignore those, we end up with 705.1. We don't care that it's a 9, it would round up, or if it was a 4, it would round out. We just cut, and then we just delete everything afterwards. And that's rounding. Now estimation is a natural extension of rounding, so it says use approximations to estimate the value. Now when it says use approximations, what that tends to mean for us to do is we want to round to 1 significant figure. So round to 1 significant figure. So in this case 8.4 just becomes 8 squared, 104 becomes 100, so it's the square root of 100, divided by, now this is a common mistake the students make, they often round this to 1, but again your significant figure is the 5. So you're rounding to 1 decimal place, which is 0.5. If we then work out the top, 8 squared is 64, plus the square root of 100, which is 10, divided by 0.5. That gives us 74 divided by 0.5. Now, dividing by 0.5 is not the same as dividing by 2. We're not halving this number. What we're doing is, you've got 2 options really in this case. You can either say, okay, well, to make it out over 1, I'm going to multiply both of those by 2, which gives you 148. So therefore 148 over 1 is 148. The other way to do it, and this works with any decimal underneath, you're just going to get rid of the decimal point by multiplying by 10. So we get 740 divided by 5. And then 740 divided by 5 gives us the same answer of 148. And again, if you can't do this in your head, just a little bus stop will give you the answer that you need. Now calculating with decimals tends to be a relatively straightforward topic, but it's one that, again, that particularly question B and question D, where students tend to make mistakes in this. But as standard, if we multiply 2 simple decimals like this, 0.4 times 0.6, well 4 times 6 is 24, and we have 1, 2 numbers to the right of our decimal point in our question, so we need the same in our answer, 1, 2 numbers. So we end up with 0.24. Now if we extend that thinking to question 2, or question B, 2 times 3 is 6, but we need 2 numbers after our decimal point. So this isn't going to be 0.6, it's going to be 0.06, which we need to be careful with. The third one, again, we're going to use the same logic, but what we're going to do is we're just going to do 237 multiplied by 15, and then we're going to do this so as if the decimals weren't there. So when we work that out, 7 times 5 is 35, 5 times 3 is 15, plus 3 is 18, carry your 1, 5 times 2 is 10, plus 1 is 11. Bring down your 0, and then 7, 3, 2. Adding those together gives us 5, 5, carry my 1, 5, and 3. So that gives us 3, 5, 5, 5. Now, we know that 1.5 times 2.37 can't be 3,555. But again, looking back, 1, 2, 3 decimal places in our question. So we get 1, 2, 3 decimal places in our answer. And the final one is division. Now when we divide by decimals, the problem is when the number we're dividing by, the divisor, is a decimal number. So we're going to make this into an integer. So we're going to times that by 10 to get 9. And obviously we need to do the same thing with the other numbers. So we get 9,476.1. We've just multiplied both of those numbers by 10 so that we now have no decimal number in our second value. And then we can just use our bus stop. 9 into 9,476.1. Well, dividing that 9 into 9 goes once, 9 into 4 doesn't go, 9 into 47 goes 5 times, remainder 2, 9 into 26 goes twice, remainder 8, and then 9 into 81 goes 9 times. Now, the big difference with decimals is that when you divide decimals, you do not move the decimal points again. So the new calculation, when you've multiplied them both by 10, gives you the exact same answer. So don't start moving the decimal place back and get whatever you 105.29 or anything. Okay, the decimal stays in exactly the same place.
The next topic we're going to look at is factors, multiples, and primes. So the first question asks us to write down all the factors of 24. Now, when we write down factors, I recommend we write them in factor pairs. So 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So your factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Next, we want to write down 10 multiples of 8. That's just your 8 times tables, because again, your multiples are just your results from your times tables. So 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. Now the third question asks you to write down all the prime numbers less than 50. You're not often going to be asked to write all the prime numbers less than 50, but you are expected to know quite a few of the first prime numbers. So usually up to 50 is enough. So first prime number is 2, remembering 1 is not a prime number. Okay, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. Now they're your prime numbers that are less than 50. Now a special one here is 2. 2 is the only even prime number. It's also the smallest prime number. So again, if they ask anything about the smallest prime number or some numbers made of prime numbers and one of them is even, obviously you know 2 has to be involved somewhere. Now the next question asks us to find the highest common factor and lowest common multiple of 24. Now I like to do this slightly differently. What I tend to do is I write this as a fraction with the smaller number on top, so 18 over 24. We're then going to simplify 18 over 24. In this case we can divide by 6, so that gives us 3 over 4. Then to find the highest common factor we can just divide the two numerators. So the highest common factor is just going to be 18 divided by 3, which gives us 6. For the lowest common multiple we can just cross multiply. So we can do the 18 times the 4. So the lowest common multiple is 18 times 4, which is 72. And that's just a nice quick way to do highest common factor and lowest common multiple when you've got two numbers. Obviously if you've got more than two numbers, you'll have to revert back to the other method of listing all the factors and listing all the multiples and finding the ones that match. Now, also similar to finding factors and multiples is your prime factorization. So what we're going to do in this case is we are asked to write 120 as the product of its prime factors. So therefore we're going to split 120 into any two numbers that make that, which is 12 and 10. Neither of those are prime, so we can split 12 again. That's 2 and 6, with 2 being prime, and 10 is 2 and 5, again both being prime. 6 then becomes 2 and 3, and there's your prime factors. If we list those then, 2 times 2 times 2 times 3 times 5. Or in index form, which is often preferred, 2 cubed times 3 times 5. Now often part B of the same question asks you to find the highest common factor or the lowest common multiple or both of the number you've just found and one new number. So in this case we have 150, so let's do 150 very quickly, which is 15 and 10. 15 is 3 and 5, both of which are prime, and 10 is 2 and 5, again both of which are prime. So again we get 2 times 3 times 5 times 5. Now when you're asked to find the highest common factor and lowest common multiple, the best thing to do is to draw a Venn diagram. So we've got our two sets, 120 on one side and 150 on the other side. And what we want to do is compare those two lists of prime factors that we found, and we're going to cross out. So this 2 is going to match with this 2, so that goes into the middle. This 3 is going to match with this 3, so that goes into the middle. And this 5 and this 5 match, so that's going to go into the middle. And then left over in the 120 is 2 2's, and left over in the 150 is a 5. So then to finish that off, our highest common factor is those middle values, all multiplied together. 2 times 3 times 5, which is 6 times 5, which is 30. The lowest common multiple is all of the numbers in your Venn diagram multiplied together. So it's the 3 in the middle, plus the 2 in the 120, plus the 1 in the 150. So you get 2 times 2 times 2 times 3 times 5 times 5. Now when I multiply these without a calculator, I like to start in the upper end. So 5 times 5 is 25, 25 times 3 is 75, and then I'm just doubling. So it's 150, 300, 600. So the lowest common multiple is 600. Now you could also use the method we showed in the last example, but this is just a method when you've got slightly larger numbers that makes your life a little bit easier. So again, the highest common factor is 30, the lowest common multiple is 600. So in this question, we're asked to calculate fractions, which fractions are an imperative part of your non-calculator assessment. So let's have a look at the 4 operations. When you add and subtract fractions, you need to have a common denominator. So in this first question, we're going to make the bottom number 35 in both cases. So then our first fraction has been multiplied by 7, our second fraction has been multiplied by 5, which gives us 28 and then 10. That gives us 38 over 35. Now that's a perfectly simplified answer. However, if you wish, you can convert that to a mixed number, which is 1, 3 over 35. Now when you're subtracting mixed numbers, you can do this without converting them. I just prefer that any time I have a mixed number, I convert it to an improper fraction. So if I convert these, remember doing 4 times 3 plus 2, that gives me 14 over 3 minus 13 over 8. Again, our common denominator in this case is going to be 24, because that's the lowest common multiple of 3 and 8. Which then gives us 112, because we've multiplied this one by 8 and we've multiplied this one by 3. Again, if you can't do these in your head, just do a little column method on the side. 14 times 8 gives you 112. 13 times 3 is 39. And then when we subtract those, 112, take away 39, gives you 73 over 24. Now we have to figure out how many 24s go into 73. Well, if we just list our multiples of 24, 24 plus 24 is 48, plus 24 is 72. So we've got very close there to 73, so that should be right. So we've got 3 of those and remainder of 1 over 24. 3 and 1/24. Now if the question is given in mixed numbers, you should convert it back at the end. That's usually the expectation. Now multiplying and dividing is different to adding and subtracting. Remember, in adding and subtracting you have to have the same denominator. That's not the case in multiplying and dividing. When multiplying, you can simply just multiply the two numerators. So 7 times 3 is 21, and multiply the two denominators. 10 times 4 is 40. Again, with division, we must convert these to improper fractions in this case. So it's 27 over 10 divided by 5 times 3 is 15 plus 3 is 18 over 5. Now, when we divide fractions, we should multiply by the reciprocal of the second fraction. Now, how we often remember that is we keep the first fraction, we change it to multiply, and we flip the second fraction. So this becomes 27 over 10 multiplied by 5 over 18. Now, instead of trying to do 27 times 5 and 10 times 18 and then simplify down, you can do something called cross-cancelling. So when you cross-cancel here, top left, divide that by 9 gives you 3, divide that by 9 gives you 2. Same thing diagonally the other side, divide that by 5 which is 1, divide that by 5 which is 2. Now we're just doing 3 times 1 on the top which is 3, 2 times 2 on the bottom which is 4. So our final fully simplified answer is 3 over 4, and it made life an awful lot easier by doing that cross-cancelling first. Staying on the idea of fractions, you could be asked to do some calculations with fractions. So in this first case, it asks us to find 7/9 of 108. Now when you find a fraction of an amount, you're going to divide by the bottom, and you're going to multiply by the top. Or divide by the denominator and multiply by the numerator. Okay, so we're going to do 108 divided by 9, which is 12. And then we're going to just do 12 times 7, which is 84. So therefore we can say 7/9 of 108 is 84. The second question asks you to write 24 as a fraction of 30 in its simplest form. So again, when we write this, we put the first number over the second number. The order in the numbers matters, so it doesn't matter if this is bigger or smaller, it's the first number over the second number. Then if we simplify these, they can both be divided by 6, which gives you 4 over 5. Which is your fully simplified answer. The third question in the bottom left is the same as the second question, but we've got decimals involved here. So again, we put the first number, 1.92, over 1.3. Now the first thing we should do here is get rid of the decimals. Now remember, when we have equivalent fractions, we have to multiply top and bottom by the same thing. And we want to get rid of all the decimals. So we're going to multiply the top by 100 and the bottom by 100. It's not just a case of removing the decimals. That gives you 192 divided by 130. Now we can simplify these. We can see they're both even, so we can divide them both by 2. Again, if you can't do that in your head, just a quick little bus tap on the side. 192. 2 into 19 goes 9 times remainder 1. 2 into 12, 6 times. So that's 96. And then the same thing on the bottom, and you get 65. So you get 96 over 65, which is your fully simplified answer. Finally then, it says if 5/6 of a number is 45, work out the number. Now that's telling us that 5/6 of some number x is equal to 45. And we're trying to find the whole number. Well, we can say that 1/6 of that number, so again 5, we can just divide that by 5 to find 1/6. So therefore that gives us 9. And then the number is the whole amount, which is 6/6. So 6/6 of x, again multiplying by 6. 9/6 are 54. So the original number is 54. Recurring decimals to fractions, again, is quite a common topic, and there are a couple of different methods for this, but sometimes they'll ask you to do it to show algebraically. So the method I'm going to show you is the algebraic method. First thing you always do, write your first x equals your original recurring decimal. Then you're going to make two equations. The first equation has no non-recurring decimal places. So in my original question I had one non-recurring decimal place, so therefore I have 10x is equal to, the 3 has now moved to the left hand side of the decimal points, and we end up with 3.45 recurring. Then I'm going to go back up to my original number, and I can see to the right of the decimal points, including the recurring pattern, I've got 3 digits. So therefore I'm going to have 1 with 3 zeros, or 1,000, and that equals 345, and then again we've still got that 0.45 recurring. Now those are the two equations I wanted because I want the same decimal place in both cases. When I subtract those from each other, so I'm doing equation 2 minus equation 1, I get 990x is equal to 342, because I'm doing 345 take away the 3, because the 0.45 recurrings just cancel. Therefore I get x equals 342 divided by 990. Now the numbers to check for when you're trying to simplify this are 3, 2, 5, 10 and 9. To check if a number is divisible by 3 or 9, if you add up the digits, so 3 plus 4 is 7 plus 2 is 9, because they add up to make 9, or a multiple of 9, it means this number is divisible by 9. So again, we can quickly on the side, 9 into 342, 9 into 3 doesn't go, 9 into 34 goes 3 times with a remainder of 7, 9 to 72, 8 times. So you end up with 38 over 110. Again, they're both even, so you can still simplify that further, which gives you 19 over 55. So your final simplified answer there is 19 over 55. Same idea with the next one, but in this case we've not got 0 point, we've got 2 point something. But we do the exact same thing. X is equal to 2.16 recurring. Again, there's one non-recurring decimal place that's to the right of the decimal point. So that means my first equation is 10x equals 21.6 recurring. So that's equation 1. And equation 2, again, I've got 2 digits after the decimal point in my original question. So therefore that's 100x is equal to 216.6 recurring. And again, we're doing equation 2 minus equation 1. That's 90x, and that's equal to 216 minus 21 is 195. Okay, then 195 divided by 90. Well, we can see they can both be divided by 5. So that gives you 18 on the bottom, and that gives you 39 on the top. Now again, they can both be divided by 3 again, and that gives you 13 over 6, which gives us our final answer in simplest form. Okay, 13 over 6. The next topic is percentages. So finding 23% of a number, I recommend, again, you can find 1%, you can find 10%, etc. But a very quick way you can do this is you can just multiply the percentage and the amount together. So 410 multiplied by 23. Okay, and if we do that, so again, using our standard column method for multiplication, when we add those together, we then get 9430. And then to make it a percentage, that means divide by 100. So we go 1, 2. So our final answer then, 23% of that is 94.30. Similarly, if you increase a value or decrease a value by a percentage, you can just find the 35% and add or subtract it. Or if you wanted to, you can make your life a little bit quicker and say, well, I want to increase by 35%, so I want to finish with 135%. So therefore I can just do 1600 multiplied by 135 and do it all in one go. So that gives you 0, 0, 0, carry your 3, that's 8, and then keep multiplying, and then your final answer then is, when you add all those together, you get 0, 0, 0, 6 carrier 1, 1 carrier 1 is 2. Again, dividing by 100 gives you an answer of £2,160, which makes sense because we've increased from 1,600, we would expect it to be bigger, which in this case is 2,160. Now this right 28 as a percentage of 20, we've seen something like this when we had fractions. Again, we do it in the same way, we start in the exact same way, we go 28 over 20, the first number over the second number. Now percent, remember, means out of 100. So the quickest way to do this is to make the denominator 100, so multiplying by 5. 28 times 5 is 140, and because we're now out of 100, that's 140%. Now this question here, while it looks like a percentage question, is actually a proportion question really. It tells you 30% of some number is equal to 45, and I want to find 110% of the number. Now there's a couple of ways you can do this. You could go, okay, well let's find 10%, which would be, well, we'll divide by 3, and then we'll multiply by 11. So the same thing works here. We're going to divide by 3, and we're going to multiply by 11. So therefore 45 divided by 3 is 15. 15 times 11 is 165. Now a way you can do this slightly quicker is you could ignore that middle line and go straight from 30 to 110. And all you do is you multiply by 110 over 30. The value you want to finish on divided by the value you started with. Now if you simplify that, you end up with 11 over 3. And when you find a fraction amount, remember you divide by the bottom times by the top. So we would divide by 3 and multiply by 11, which is exactly the same thing we did here, without having to think too much about it. So again, it's just another method that we can use that may save us a little bit of time. Some more percentages. So the price of a book is £18, including the 20% VAT. Work out the cost without VAT. So this is an example of a reverse percentage. We're going backwards. So because this includes 20% VAT, that means it's 120%. In any one of these reverse percentage questions, we're trying to find 100%. So 120% is equal to £18. I want to find 100%. So therefore, I can use the same idea I just had, which was multiply by 100 over 120. If we simplify that down, it gives you 5 over 6. So we can use the same scale factor here, multiply by 5 over 6. 18 divided by 6 is 3. 3 times 5 is £15, which was the original price of the book. So again, you can see there it saved us a little bit of time. The next one, investing at simple interest. Okay, simple interest just means you get the same amount every year. So we start by finding 4% of 2,000, which is £80. And then that just means we're going to add on £80 every year for 5 years. So we can do £2,000 plus that £80 for 5 years. 80 times 5 is 400. So we're doing 2,000 plus 400 is £2,400. Next one, percentage increase. Sometimes it'll ask a percentage decrease. Sometimes it'll say percentage change. Okay, if it asks for change, you then have to mention if it's an increase or decrease. But very simply, we just do the change over the original and multiply that by 100. So the change here between 80,000 and 90,000 is 10,000. The original number is 80,000, I should say, multiplied by 100. Now we can simplify this down by cancelling all our zeros, and we have basically 1 over 8 times 100, which is 100 over 8. Now to simplify that down, we can just use our bus stop. We'll do it over here on the side. 8 into 100. Okay, put a couple of decimal places as well. 8 into 1 doesn't go. 8 into 10 goes once, remainder 2. 8 into 20 goes twice, remainder 4. And 8 into 40 goes 5 times. So we've got 12.5. So therefore our percentage increase is 12.5%. Okay, you may have already known that 1/8 is 0.125. So then that would have saved you a little bit of time. But again, that's 12.5%. Finally, we've got Tom, who claims that if a quantity is increased by 30% and then by 40%, the overall increase is 70%, and showed this incorrect. This is an example of compound interest and combining percentages that makes a mistake. So an increase of 30% is a multiplier of 1.3. An increase by 40% is a multiplier of 1.4, and an increase of 70% is 1.7. Now, if we want to combine the 30 and the 40, we do 1.3 times 1.4. And we looked at multiplying decimals earlier on. Again, we ignore the decimal place initially, and then we do our calculation. So 4 times 3 is 12, so 2 carry 1. 4 times 1 is 4, plus 1 is 5. Bring down your 0, 3, 1. If we add those together, you get 182. Putting our decimal point back in, we get 1.82. And 1.82 is not the same as 1.7. So we know he's wrong. 1.82 is actually an 82% increase. And the reason that happens is because we're increasing we're not increasing 100% by 40%, we're increasing 130% by 40%. So it's an 82% increase. Now, ratios tends to be a topic that students struggle with a little bit in the exam. And actually, it's not about the ratio and the number, it's about how you interpret each of those values in the question. So you can see here, there's 3 questions. You've got the same people, the same ratio, and the same amount of money. What you need to figure out in each case is what does the money represent. So we write our ratio. Albert to Nicola is 7 to 2. Now, this £90 in this case represents the total. It's what they both share. So then our scale factor, that thing we're going to multiply by, is always going to be 90 divided by, and in this case it's the total, which is 7 plus 2, which is 9. So that means I'm multiplying by 10 each time. So I'm scaling this up by 10. And that tells me that Albert gets 70 and Nicola gets 20. So Albert equals £70 and Nicola gets £20. Second question, again, we can start with Albert to Nicola, 7 to 2. Now again, our scale factor is going to be that 90 divided by something. Now in this case, the £90 is what Nicola gets. And if we look at Nicola, he's got 2 parts. So therefore we're dividing the 90 by 2 to give us a scale factor of 45. So we can scale this up by multiplying by 45 and multiplying by 45, which gives us 90 for Nicola, and then Albert is, we can just do a quick column method on the side, which is 45 times 7. 7 5s are 35, carry a 3, that's 28, that's 31. So you get 315. Question asks, how much did Albert get? So Albert is equal to £315. Finally, same idea with the last one, but there's a different word in here which helps us, which tells us that Nicola gets £90 less than Albert. So this idea of less, if you get those words more or less, it means you're going to find the difference between them. Okay, so the scale factor then is 90 divided by 5, because we've taken that 7 away from 2, which gives us an answer of 18. And now we're multiplying both sides by 18. Okay, so that gives us 8 times 2 is 36. 7 times 18, well again we can do that on the side. So 7 8s are 56, carry your 5, that's 7 plus 5, which is 12, so it's 126. Now the question asks how much they share in total. So in total, they get 126 plus 36, which is £162 in total. So again, the key here is not about the £90 of the ratio, it's what is the relationship between the £90 and the ratio. In the first case it was the total, in the second case it was one person's share, in the third case it was the difference because of that word less, but equally the word no could have been used. Now, simple proportion we can look at. We've got two options. You've got direct and inverse proportion. You're often not told which one it is, but it's usually quite obvious. So direct proportion means as one goes up, the other goes up. Inverse proportion, as one goes up, the other comes down. So looking at the direct proportion, it says a machine produces 250 biscuits per minute. How many biscuits will it produce in an hour? Well, it's given us 250 biscuits in 1 minute. An hour is 60 minutes. So therefore, all we're doing is multiplying by 60. So we can just do 250 times 60, which gives us, carry 3, that's 12, 15. So you get 15,000 biscuits. So therefore, how many biscuits will it produce? 15,000 is my answer. In the same sense as how long will it take the machine to produce 50,000 biscuits, we can do the same setup. 150 biscuits is equal to 1 minute. I've got 15,000 biscuits, and I want to find out how much time that takes. Now, we saw this earlier on. To find our scale factor, we do 50,000, I should say, divided by 250, and then if we simplify that down, that's 5,000 over 25. We could divide them both by 5 to make it easier, which is then 1,000 divided by 5, and 1,000 divided by 5 is 200. So we can see we just multiplied by 200. Doing the same on the other side, multiplying by 200, that means it's going to take 200 minutes. It doesn't ask us to convert to hours and minutes, we can just leave it as 200 minutes, or if you wanted to, you can say it's 3 hours, 20 minutes. But unless it asks, I recommend you just leave it. Now, inverse proportion is the opposite. The interesting thing in this one, it tells you about 1,000,000 biscuits, but the number of biscuits doesn't change. Now, if the number of biscuits change, then that is a directly proportional relationship, and sometimes they'll add that into the mix. But in this case, it's just inversely proportional. It's inversely proportional because we're looking at the machines and the time. When you notice inverse proportion, because if I have more machines, it'll take less time, what I try and work out is the total work. So the total work is 10 machines making working for 6 hours. So 10 times 6 hours is 60 hours of work. And that's a great start, because what we can then do is, okay, well, if I've got 12 machines, I can just do my 60 hours divided by my 12 machines. That just gives me 5 hours, because it's 5 hours per machine. Equally, if I was given the time like I am in the second one, so 4 hours, I still have 60 hours of work to do, but I want to get it done in 4 hours. So I just divide that by my 4 hours, and 60 divided by 4 is 15, and I need 15 machines to do that work. Okay, because I'm doing 60 hours into 4-hour slots, that means 15 machines, because each machine will do 4 hours worth of work. You can see a similar thing here in tables. So direct proportion means we multiply them all by the same thing. So to get from 22 to 110, we multiply by 5. So same sense here, multiply by 5, that gives us 75. On this side, because we're going backwards, we're going to divide by 5, which gives us 7. For an inversely proportional relationship, like we saw, we're going to find that total work. So 5 times 12, which we have, is 60. So therefore all of these will need to be 60. And then it's really obvious to see, well, it's 6 times 10. This one sometimes causes issues trying to get from 600 to 60. We can't just write divide by 10 here. So you can either write 0.1 or you could write 1 over 10. Again, you can use what we saw before, which is the new divided by old. I'm trying to get to 60. I'm on 600. And if I simplify that down, it gives me 1 over 10. And then I can just write my answer as 1 over 10 or 0.1. Standard form is pretty straightforward and it usually comes up quite early on in the paper. So again, it's just remembering to do it. Remember, it has to be written between 1 and 10 and then times 10 to some power. So our decimal point goes 1.53 times 10, and then we count the digits after the 1. 1, 2, 3, 4, 5, 6, 7, 8. So it's 1.53 times 10 to the 8. With a smaller number, when you've got 0 point something, that just means you're going to have a negative power. And what I like to do is here I go 4.3 times 10 to the power of negative, and then I just count the zeros. 1, 2, 3, 4, 5. Now note that I do include the 0 to the left of the decimal point, so that's minus 5. Using a similar idea to the opposite, I've got 3 jumps here because it's 10 to the power of 3, so I have 37, that's 1 jump, and I've got 2 left over, so there's my 2 zeros. In the same sense here, what I like to do is I've got negative 4, so I write 1, 2, 3, 4 zeros. Then I write my other digits, in this case my 51, and then I just put a decimal point after the first 0. So I get 0.00051 as my answer there. Now, if you're asked to calculate in standard form, add, subtract, multiply, divide, I recommend you take them out of standard form, put them into ordinary form, do the calculation, and then put them back into standard form at the end. There are quicker ways, but that way is, in my opinion, the most effective and the most straightforward. Bounds and error intervals, very straightforward. I recommend that you use a number line for this. So you've got 8.3 in the middle. For one decimal place before that you get 8.2. Above that you get 8.4. The midpoints then are 8.25 and 8.35. So therefore in this case the lower bound is 8.25 and the upper bound is 8.35. And you can just use this little number line every single time. Same idea with the mass of the watermelon. In this case it asks to find the error interval, which is slightly different. But again, if we've got our number line, 9, the given value goes in the middle, okay, to the nearest kilogram. So a kilogram below that is 8, a kilogram above that is 10. Finding your midpoints, 8.5 and 9.5. Now for your error interval, you write your lower bound, 8.5, is less than or equal to m. It's always less than or equal to, and then is less than 9.5. And this middle bit is always the same. The letter might change. This told us it was m, but it could be x, it could be t. But it's always the lower bound, the upper bound, and then it's always less than or equal to on the left, and then less than on the right. Now that's when we have continuous values, things like mass, length, etc. For discrete values, now discrete values are unique, but this is where you've got, it tends to be people, objects, and money. So what they'll ask instead is not the upper and lower bound, they'll ask for the minimum and maximum numbers. Again, the same idea works here. We've got 50 in the middle, so to the nearest 10, that's 40 below and 60 above. So your middle values are 45 and 55. So because you can't have a decimal number of people, the minimum is still 45, but the maximum is not 55, it's 54. You must take 1 away from that because 55 would round up, 54 rounds down, and that you can't have 54.999 like you would have had in the continuous values. So therefore that's why we take 1 away when we're talking about people, objects and money. Again, similarly in this one you can see we've got money. Abdul's saving £450 to the nearest 50, so that's 450. Again, because it's the nearest 50, it's 50 below here and 50 above here. So your midpoints are 425 and 475. So the minimum value is £425. The maximum value, now in this case we're not taking away a pound, we're taking away a pence, so it's 474.99, which is our answer there. Taking this one step further, you can do bounds calculations. Now what causes people issues here is they choose the wrong values. Now in this case I'm going to just find my upper and lower bounds for these. So for P, the lower bound is going to be 150. Again, I could have just used my diagram. and then my upper bound is going to be 250. For S, my lower bound is going to be 5, and my upper bound is going to be 15. Now, to find the upper bound for V, because I'm doing division, I need the numerator to be as big as possible, so I use the upper bound for P, which is 250, and I need the denominator to be as small as possible, so I use the lower bound for S, which in this case is 5. And then I just work it out, 250 over 25, which is 10. So the upper bound for V is 10. Now, on the right hand side, and feel free to pause this and just have a read through it, that's the key idea of how you find them. When you add and multiply, you use the matching ones, so the two lower bounds for the lower bound, the two upper bounds for the upper bound. For subtraction and division, you do the opposite, so you use lower bound and upper bound, or upper bound and lower bound. And what I suggest, this is kind of your general rule, you start with the value you're looking for. So if you're finding the upper bound, you're going to do upper bound over lower bounds, etc. Again, if you add or multiply, you use the matching value. If you subtract or divide, you use the opposite value. So if I'm trying to find the upper bound for a subtraction problem, I'll start with the upper bound and I'll take away the lower bounds. If I'm trying to multiply and I'm trying to find the lower bound, I just use the two lower bounds. But again, take some time to pause and read through that, and that should hopefully help guide your decisions. Index laws, now you're asked to simplify these, which are really straightforward. One of the first things you probably learned when you were introduced to algebra. So when we're multiplying, we use the same powers. With the same base, we add the powers. So that's 5 to the 8. When we divide, we subtract. So in this case, you're doing 5, take away negative 2. So 5 minus minus 2. That gives you 5 plus 2, which is 7. So that's x to the power 7. When there's a bracket between them, we're multiplying those two powers. So you get x to the 24. And then in this idea, fractions are the same as division. So we're doing 7, take away 9, so that's x to the power of minus 2. Or you could write it as 1 over x squared. But this is usually the answer they wanted us. Again, now we've got slightly different ones here. What we have is a coefficient. We've got a number before each of these. So in this case, we still have y to the 7, but we also have to multiply the 3 and the 4, which is 12. Same idea with the next one. We do the 8 divided by the 2, which is 4. Subtracting our powers, we get y to the 7 again, because 5 take away negative 2 is 7. But it's just that idea of those coefficients at the start. This one is often one that people make a mistake on. It is y to the 15, but you also have to work out 3 cubed, which is 27. Now what I recommend you do is you think of this as 3y to the 5 times 3y to the 5 times 3y to the 5. And now it makes sense why we do 3 times 3 times 3. Okay, so we just remember to cube that coefficient as well. And then finally here, we can't divide 18 and 5. We can subtract these powers. There's 5 on the top, there's 3 on the bottom, so we're left with 2 on the bottom. So we end up with 18y squared over 5, which we can leave as our answer. We don't need to write as a decimal. It's usually preferred to write your answer as a fraction. Now those were simplified. Finally, you could have a combination of those, and we have, in this case, z to the 14 over z to the 20, which then simplifies to z to the negative 6. Same idea on the next one. You're going to work at the top and bottom separately, so you get 18 z to the minus 2 over 9z to the minus 4. Now we're going to do 18 divided by 9, which is 2. And then z to the minus 2 take away minus 4. So we've got minus 2 take away negative 4. Well, that's minus 2. They become a plus. So minus 2 plus 4 gives you z squared. So that whole thing simplifies to 2z squared. Now, the other version you could be asked is to evaluate using laws of indices, or to work out. Now the difference here is that you can't just leave your answer as 2 to the power 5. You actually need to work out what 2 to the power 5 is. So that's 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, 8, 16, 32. So that's 32. Same idea with the next one. You get 3 squared, which is 9. Again, we're having to work out the answer. This one we get 2 to the 8. Again, just doing that 2 times 2 times 2 times 2. So that was 32, 64, 128, 256. So 2 to the 8 is 256 because we're doubling each time. Finally, this last one's a little bit weird. Take away your powers. You get 3 to the power of negative 3. Now, what we want here, because that's a negative power, we should have 1 over and then 3 cubed, which is 27 as our simplified answer. Okay, but you could have instead said here, well, this top number just cancels and becomes 1, and this becomes 3 cubed. But it's often seen that you should write it as a negative power and then obviously convert it to that reciprocal. These tend to be your kind of more difficult, and particularly at the kind of middle to the end of the higher paper. And they're only asked in the higher paper your indices and your evaluations. So with these, the bottom number is your root, the top number is your power. So I'm finding the fourth root of 16, and then I'm going to cube my answer. Now the fourth root of 16 means what times itself 4 times gives me 16? Well, that's 2, and then 2 cubed is 8. In this case, same thing, top number is the power, bottom number is the root, and this minus means we use the reciprocal, which means flip the fraction. So we end up flipping first 16 over 25. Now when I talk about flipping the fraction, I'm talking about the base, not the power. So it's just this. Then we're finding the square root of both of those numbers, because that's what the 2 on the bottom means, and then we're going to cube both of those numbers. So therefore, working that out, that gives you 4 cubed over 5 cubed, which gives you 64 over 125. And it's just about taking your time with each of those and making sure you do all 3 steps to make sure you get all the marks. And the last part of index loss is changing the base. Now this wants you to write as a single power of 2, which means it wants you to finish your answer as 2 to the power of something. Well, if you look at your powers of 2, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4 is 16. So what I'm going to do is I'm going to change this 8, check on my list, is 2 to the 3, so that becomes 2 cubed to the power of 3 times. The 4 then becomes 2 squared to the power of 7, and now I just use my standard laws. That's 2 to the 9 times 2 to the 14, and adding those together you get 2 to the power of 23. Now this said write as a single power 2, not evaluate, so you don't have to work that out. Similar idea in the next one, looking at your powers of 3, 3 to the 1 is 3, 3 squared is 9, 3 cubed is 27, and 3 to the 4, even though we don't need it here, but it's worth knowing, is 81. So with this one then, we're going to do 9, so 9 is 3 squared to the power of 3 over 2, divided by 27, which is 3 cubed to the power of 5. Evaluating these, 2 times 3 over 2 is 3 cubed, divided by, and then times those powers, 3 to the 15. When you then subtract those from each other, you get 3 to the power of negative 12, which is what you want, because it wants it as a single power of 3, which means 3 to the power of something. You don't need to make it 1 over 3 to the 12. The next topic is surds, which is a topic that's only really useful when it comes to the non-calculator paper, because on a calculator paper you can just put it on your calculator and get your answer. Now, when simplifying surds, what we need to do is find the factors of 150, and we're trying to find one of the factor pairs that gives us a square number. So 1 times 150, again, no square numbers. 2 times 75, no square numbers. 3 will work, you get 3 times 50, again, no square numbers. 4 doesn't give us any answer. 5 times 30 is another one. Then we get 6 times 25. And now we've found our largest square number. So therefore this becomes the square root of 25 times 6. And the square root of 25 is just 5. And then root 6. That's your simplified surd. Now it's a good habit to always, if you have surds and you're asked to simplify them or collect like surds or multiply, divide, to simplify them first. However, in some cases that's not the most efficient method. If we look here and we divide these surds on the right hand side, what we're going to do is we're going to divide the coefficients first. So 6 divided by 3 divided by 2, apologies, is 3. And then your surds, root 50 divided by root 2 is root 25. Now we know the root 25, the square root of 25 is 5, so this just becomes 3 times 5, which is 15. So actually, instead of simplifying first, it was easier just to do the calculation and then simplify at the end, which ended us not having a surd. So similar idea here, we've got some surds, we've got some fractions, so we're going to simplify the surds here, and that's the first step we're going to do. So 90, well that's 1 times 90, 2 times 45, 3 times 30, 5 times 18, 6 times 15, 7 doesn't give us any answer, and then 9 times 10. So this is our square number here, so 9 times 10. So this becomes the square root of 9 times 10. Square root of 9 is 3, so that's 3 root 10 over 3 minus, and then if we do this one, so 40, 1 times 40, 2 times 20, 4 times 10, and again, there's your square number. You also have 5 times 8, but that's not square, neither of those are square. So therefore the square root of 4 is 2, so you get 2 root 10 over 2, and then when we cancel these down, you end up with the square root of 10 minus the square root of 10, which interestingly here gives us 0. Finally, we've got these ones. Now, when we simplify surds like this, where you've got a surd on the bottom, this is where we have to rationalize the denominator. Now, if you've just got a singular surd, that makes it nice and easy. You can just multiply by that surd on the top and the bottom, because that gives us 5 root 3, and then root 3 times root 3. Or if we think about that, that's root 3 times root 3. That's the square root of 9, and the square root of 9 is 3. So essentially, we've just cancelled out the square roots. So we just end up with 5 root 3 over 3. In this case, because we've got an add, what we're actually going to multiply by is the same thing with a subtraction in the middle. And then when we expand that, we multiply the top and we get 2 times 3 is 6, and we get 2 times minus 5, which is minus 2 root 5. So minus 2 root 5 over. Now the bottom, you can expand it as brackets, but there is a shortcut which we'll look at. So if I expand those, I end up with 9 minus 3 root 5 plus 3 root 5 and then minus 5. These two will cancel out, and they will always cancel out, and we just have 9 take away 5, which is 4. Now what we can do here is, to do it quicker, we can say, well, 3 squared is 9, the square root of 5 squared is 5, and then we can just put a minus between those, which then gives us 6 minus 2 root 5 over 4. So we could have done this mentally instead of doing it here on the side. We can then simplify these by dividing them all by 2, and we get 3 minus 1 root 5, or just root 5, over 2, because all 3 terms were divisible by 2. And the next skill is expanding brackets, and that can appear in a number of different ways. And what we can do with that is we have to expand, and then sometimes we'll have to collect like terms. But it means we're going to multiply the number on the outside of the bracket by the numbers on the inside. So if we multiply these terms, we get 3x times 2x, that's 6x squared, and then 3x times negative 4y is negative 12xy. The second one looks a bit more complex, but it's very, very similar. You just treat these as two separate questions. So we've got 2 times 3 is 6x, 2 times 1 is plus 2. Now here, when we multiply in, we're not multiplying in 4, we're multiplying in the negative 4 as a whole term. So therefore, we get negative 4 times 5 is negative 20x, and then negative 4 times negative 7 is positive 28. Collecting our like terms then, 6x take away 20x is negative 14x, and then minus 2 plus 28 is plus 30. Finally, we've got double brackets beside each other. In this case, we're multiplying the 2x in the first bracket by both of the terms in the second bracket. That gives us 6x squared minus 10x. And then the two terms in the bottom, 3 times 3 is, or the second term by both of them, which is 9x minus 15. And then if we do them in that order, we'll always collect together the two middle terms and get 6x squared minus x minus 15. The final way that you could have expanding brackets is you have triple brackets. Now to expand triple brackets, you just pick any two of those brackets, expand those together, and then multiply your answer afterwards. So if we expand these first two brackets together, we end up with 6x squared plus 6x minus 2x minus 2. And if we collect like terms, we get 6x squared plus 4x minus 2. We're then going to multiply that by the other bracket, which was x minus 5. And we expand that in, x times all of those is 6x cubed plus 4x squared minus 2x. And then multiply them all by 5 gives you plus 30x squared plus 20x minus 10. Finally, collecting our like terms, you get 6x squared plus 34x squared. Sorry, that should be 6x cubed, not 6x squared. plus 34x squared plus 18x minus 10. And that gives us our final answer. No matter what order you multiply the brackets in, you should end up with the same answer. The next skill we're going to look at is factorizing. Now factorizing is just the opposite of expanding. So where expanding was taking the numbers out of brackets, in this case we're trying to put it back into brackets. So we have to think what will divide both of those two terms. So we can factorize both of these by 3, and that gives us x plus 4. Second one is exactly the same. What can I take out of both? Well, I can take 5x out of both of them, and I get 3x plus 4. Again, no common factors left. Now when they say fully, it means you must take everything out. So you could have just taken 5 out, you could have just taken x out, but that's not fully. Fully means you have to take the 5 and the x out. Same thing in the last one, we have to factorize fully. So 4 divides 8, 20 and 32, and we can take an x and a y out of all of the terms. That leaves us then with 2xy squared plus 5. Both of the x and y have been taken out, so there's no variables left there. And then minus 32 divided by 4 is 8. The x is gone, we're left with just a y. And that's our final answer. So again, we're trying to take out the highest common factor in each of those cases. So factorizing means put it into brackets. You could also be asked to solve equations. Now the difference between equations and expressions is that equal sign that you have. Okay, now if you want to solve these, that just means find out the value of x. So to solve these, we're going to think, well, okay, I want to try and get this 5x on its own. So we're going to subtract 12 from both sides, and we get 5x is equal to 15. And then to find 1x, we divide both sides by 5, and we get x is equal to 3. So 3 is our final answer. And we can check that by subbing that back in. 3 times 5 is 15, plus 12 does give us our 27. Same idea with the next one. Okay, we're going to expand those brackets first to get rid of those. We've got 6x plus 3 over 5 equals 10. Now because this whole thing is over 5, the first thing we're going to do is get rid of that 5. So we get 6x plus 3 equals 50. And now we're back to what we had in the previous question. Just take away 3 from both sides. We get 6x equals 47. So x equals, again, dividing them both by 6, x equals 47 divided by 6. Now we don't know what that is as a decimal. Okay, it's quite a long thing to do, and there's no expectation that you write as a decimal. You can just leave it like that as an improper fraction. Okay, it can't be simplified because 47 is prime, as we've seen earlier. Finally, this last one, you've got brackets on one side, and there's an x on both sides. So let's start by getting rid of the brackets. So if we expand the brackets, you get 16x minus 20. Now I prefer my bigger x to be on the left hand side, so I'm just going to flip this around and just make it 16x minus 20 is equal to 4x plus 18. The signs don't change because I've just flipped the whole thing around. Now I'm going to solve it. So I've got two x's, I'm going to get rid of the smaller x. So I'm going to take away 4x from both sides, and that gives me 12x minus 20 equals 18. And now I'm back to the same thing I had in the first question, just solving a simple linear equation. Adding 20 to both sides gives me 38, and then dividing both sides by 12 gives me x is equal to. Now 38 over 12 is fine, we can leave that as an improper fraction. However, we can simplify this. If we half both of these, we get 19 over 6, which is our simplified answer. And even though it didn't say it, the expectation is that we would simplify our answer where possible. Simplified just means that we get rid of the highest common factor out of the two of them. Okay, so they can't be divided any further down. It doesn't mean it has to be a mixed number or a decimal. Next one, rearranging formulae, is very similar to solving equations. It's just about getting that thing on its own. So in this case, we're trying to get m on its own. So what we can do is, if we just imagine that we covered this up, we want to get rid of this positive c. When we bring that to the other side of the equal sign, it becomes negative c. So we've got y minus c equals, and then this thing just comes back, mx. To then get m on its own, like we did before, we're just going to divide both sides by x. And that tells us then that m is equal to y minus c over x. It's good practice to always have your subject first. Same idea with the next one. We've got v squared equals u squared plus 2as. We're trying to make a the subject. So again, we're going to get rid of the a term, as if it doesn't exist. And we're going to look right, we've got u squared. So the opposite of plus u squared is minus u squared. So we get v squared minus u squared is equal to, this thing can come back, 2as. Now in your exam, I don't recommend you cross it out. Just use your finger to cover it up so you just can't see it for a minute. Then I'm trying to just keep the a here. Now these are all multiplied by them, so I'm trying to get rid of the 2s. So to get rid of the 2 and the s, I'm just going to divide the whole thing by 2s. So that gives me v squared minus u squared over 2s is equal to a. And that's our final answer. Finally, you get these ones, which are slightly longer, and they tend to be kind of 3 or 4 marks. And it's where your subject is x, and that appears twice in your question. So what we're going to do is we're going to get rid of any brackets and any fractions first. So we're going to multiply across by this, and we get xy minus 5y is equal to 2x plus 3. So I've just multiplied the y by the denominator. Then I'm going to rearrange it so that my x terms are together. So I've got xy. This positive 2x becomes negative 2x. This negative 5y can go to the other side, which becomes positive 5y plus 3. Now's the trick. How do I get 2x's into 1x? Well, I'm going to factorize out x. So I take out x and I get y minus 2 is equal to 5y plus 3. And then my final step then is that this bracket becomes my denominator, and I get 5y plus 3 over y minus 2. Now, while you might look there and go, oh, well, the 2 and the 5 just swapped around, changed for x and y, that's not always going to be the case. So don't try and think that there's a shortcut there, okay? Because if they make any slight amendment to that, it doesn't work in the same way. Okay, so we just follow those same 4 steps, bring the denominator across and multiply, rearrange to get your x's together, factorize out your x, and then put your bracket underneath the fraction, and that should give you your correct answer every single time. The equation of the line is the next part. So with the equation of a line, you need to do 3 steps. Step 1, you're going to find m, the gradient. Okay, sometimes you're given that, and that's the bit that varies. The next thing you're going to do is find c, and then your third one is you're going to write your expression, or write your equation. Okay, so if we look at that, in this case we're given the gradient, so m equals 4. That's nice and easy. Now to find c, we're going to substitute m and the given point, this is your x and y values, into y equals mx plus c, which is our standard equation for the equation of a line. So when we sub that in, we get minus 3 is equal to 4 times 5 plus c. And then solving that, minus 3 is equal to 20 plus c. So rearranging that to take 20 away from both sides, c is equal to minus 23. So now we have m and we have c. So our final equation then is y equals 4x minus 23. And it should always end up in the form y equals mx plus c, where m and c, you write the values for them. The one on the right hand side, we're going to do exactly the same thing. And again, we're just going to use the same 3 steps. Step 1, we're going to find m. And as I said, this is the bit that varies. The rest of it's always the same. So in this case, I'm given 2 points. So I need to find m, the gradient, which is the change in y divided by the change in x. Okay, so the change in y divided by the change in x. The change in y, so to get, my y values are second, so to get from 15 to from 5 to minus 15, I'm taking away 20. And to get from 2 to 12, I'm adding 10. So it's minus 20 over 10, which is just negative 2. So m is negative 2. To find c then, we're going to sub that into y equals mx plus c. Now it doesn't matter which point I choose, but I'm going to use this one because they're smaller numbers. So 5 is equal to minus 2 times 2 plus c. 5 is equal to minus 4 plus c. And then when you rearrange, you get c equals 9. So my final answer then again is y equals minus 2x plus 9, which is my final equation of that line. 2 other variations that we can see when it comes to the equation of a line and finding the gradient is if you've got parallel or perpendicular lines. If they're parallel, that just means they have the same gradient. So therefore, we know that m is 5 because it's given to us here. So therefore, we can then say, well, y equals mx plus c. This is my x and my y. So minus 3 is equal to 5 times minus 3 plus c. Minus 3 equals minus 15 plus c. Adding 15 to both sides, you get c equals 12. So my final equation is y equals 5x plus 12. Now in this one, I'm asked perpendicular. Now, when we have to find the perpendicular gradient, we use the negative reciprocal. Okay, that means if we have a fraction, we just flip it over, or if we have a number, we make it 1 over that number. And then if it's positive, we make it negative. If it's negative, we make it positive. So in this case, the gradient we're given is 3. So m1, the first gradient, is 3. So we're going to work out m2, which is our perpendicular gradient, which is going to be the negative reciprocal, so negative 1 over 3. And now we do exactly the same thing we did before. Y equals mx plus c, minus 11 equals minus 1 over 3, minus 1 over 3 times 6 plus c, minus 11 equals minus 2 plus c, so rearranging that gives you c equals negative 9. Now my final answer is y equals minus 1/3 of x, take away 9. And that's the final equation of my line. Moving on then to the next topic, we're going to look at sequences. Now, arithmetic sequences means you add something every time. So looking at this, we're adding on 7, 7, 7, and 7. So that works. And then to find the nth term, this 7 means it's going to start as 7n. To find the bit that goes in the end, you just think, well, what number would be before the 9? Well, it would be positive 2. So therefore, it's just 7n plus 2. Now you could then be asked to use that nth term to find the 9th term of the sequence. Now you could just keep adding 7 and 7 and 7 and 7 until you get there. But the advantage of using this nth term is you can then substitute this in for n. So we get 7 times 9 plus 2. 7 nines are 63 plus 2. So that means the 9th term is 65. So that's the 9th term. The second question says, show that 141 is not a term in the sequence. Now remember, the terms in the sequence is term number 1 is n equals 1, term 2 n equals 2, term 10 is n equals 10. So we want to figure out, well, what would n be for 141? So we do 7n plus 2 equals 141. So we let our nth term equal that number, and we're going to solve that. 7n is equal to 141 minus 2, which is 139. And then we're going to divide both sides by 7. So n equals. So if we then do a little bus stop, 7 into 139. 7 into 1 doesn't go. 7 into 13 goes once, remainder 6. And 7 into 69 goes at 9 times, remainder 6. And because there's a remainder, this is essentially 19 and 6/7. Okay, so because that's not a whole number, so not an integer, a positive integer, 141 is not in the sequence. Okay, if we got an answer where it was like we divided it by 7, we got 20, for example. If we had 20, then we would have just said, yes, it is in the sequence because n was a whole number. And the next type of sequence is a quadratic sequence. Now there's lots of different ways to find quadratic sequences. I'm going to show you two methods in this. So your quadratic sequence should have what's called a second difference. So that's 4, that's 8, that's 12, and that's 16. Okay, then if we look at the differences of those, we've got 4, 4, and 4. Now, this is where the methods differ. So I'm going to change color. So, method 1, I'm going to call step back. So, we're going to take one step backwards, which gives us 4. 4 take away 4 is 0, and that take away 0 is 11. And then we have to remember the following three things. This is 2a, this is a plus b, and this is c. So in this case, we have to figure out what is a, what is b, and what is c. A, well 2a is 4, so a is 2. C we're told at the top is 11. This is the only thing we have to think about. So a plus b is 0, so 2 plus what gives me 0? Or how do I get from 2 to 0? I take away 2. So my nth term then is 2n squared plus, 2n squared minus 2n plus 11. Okay, because it's always in the form an squared plus bn plus c. The other method you can use method 2, is the table method. Okay, and what you can do is you can build the following table. You start with your original sequence, and again, you only really need the first 4 terms of the sequence. That's normally enough. So that's 11, 15, 23, and 35. Now that we have our original sequence, we're also then going to, using this idea of 2a, that means that because I've divided by 2, that 4 is 2, so we end up with 2n squared, because it's half of the second difference on the bottom. We're then going to sub in n equals 1, n equals 2, n equals 3, n equals 4. So 1 squared is 1 times 2 is 2, 2 squared is 4 times 2 is 8, 3 squared is 9 times 2 is 18, 4 squared is 16 times 2 is 32. And then we're going to find the difference between those two. So we're going to do 11, take away 2 is 9, 15, take away 8 is 7, 23, take away 18 is 5, and 35, take away 32 is 3. Now with this bottom sequence, that will always be linear. So we're going to find the nth term of this linear sequence, which is minus 2, minus 2, minus 2. And like we said before, if I go back a step, that gives me 11 here. So it's positive 11. So therefore my nth term is 2n squared from here. And then I stick on this nth term that I've just worked out, which is minus 2n plus 11. And again, either method gives you the same answer. It's just whichever one you're more familiar with and whichever one you prefer. Now, we spoke about factorizing earlier. We're going to look now at factorizing quadratics. Again, remember, factorizing means putting into brackets, and a quadratic is where you've got an x term, an x, and a constant. So if I factorize this, I end up trying to find two numbers that multiply to make 6. So that's 1 times 6 and 2 times 3. And I need them, because of this sign, I need them to subtract to make minus 5. So that's going to be, well, x minus 6 and x plus 1. And that's my answer. Now in the second question, I've got a coefficient of x squared. So I'm going to multiply those two things by each other to make 20. And I'm looking at the factors of 20. 1 times 20, 2 times 10, 4 times 5. And I need them to add to make negative 9. So I'm going to use 4 and 5. Now I've got 2x minus 4 and 2x minus 5. Now that doesn't work because 2x times 2x is 4x squared. So I need to divide one of my brackets by 2, which gives me x minus 2 and 2x minus 5. Similar idea with the last question, but there's something different that happens as we get further through it. So 8 times 3 is 24. Factors of 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6. And I need those factors to subtract to make 10. Okay, well that's going to be 2 and 12. So I'm going to have 8x plus 12 and 8x minus 2. Now the problem here is you can't divide 12 by 8 and you can't divide 2 by 8. But we can split the 8 into a 4 and a 2, because 4 times 2 is 8. If we divide the first bracket by 4, we get 2x plus 3. And the second bracket by 2 gives you 4x minus 1, which gives us the answer we needed. Similarly to quadratics, you could also be asked to complete the square. Now, completing the square is a very straightforward process. The quickest way to do this is we're going to open our brackets, we're going to have x, we're going to have a squared, and we're going to have a minus. That bit's always the same. The bit that goes into our bracket is, well, we're going to half this 12, which is plus 6. We're then going to subtract this 6 that we just found, squared, which is 36. And then we're just going to put this 15 on the end, which is minus 15. And then to finish off, we just collect our like terms, which is x plus 6 squared minus 51. It could then ask us to find the turning point of the same quadratic. Notice they're the same quadratics. The turning point then, very simply, is the opposite of what we had in our brackets. So instead of being plus 6, it's minus 6 for x. And then whatever was on the outside is our y value, minus 51. This question is slightly different because you've got 2x squared. But all we're going to do is we're going to factorize out our 2. And we get x squared plus 8x minus 17. And now we're just going to complete the square as we did before with that bit on the inside. So to save us some time, I'm not going to go through the whole steps. We get x plus 4 squared minus 16 minus 17 is minus 33. So that's our completed square. And then we're going to multiply our 2 back in, which gives us, we're not going to multiply the 2 into the brackets, we're just going to put it beside it. And then 2 times 33 is minus 66. Now to find the turning point, we don't need to change anything from what we've done before. The 2 has no impact now on our final answer. So our turning point then is minus 4 and minus 66. And that's our answer for completing the square and finding the turning point. Algebraic fractions work in a very similar way, particularly the first one that you see here. So the first one asks you to simplify that. Now you'll notice there that we've got a quadratic and a difference of squares. So in this case what we'll do is we'll factorize both of those. Again, I won't go into too much depth about factorizing the quadratic because we've done that already. So it's 3x and x. Two numbers that multiply to make 12 are 4 and 3. So we're going to have plus 3 and negative 4. And that's going to make what we needed on the top. And then on the bottom, the difference of two squares, because this is 9x squared is all a square number and 16 is a square number, and we can subtract them. So therefore we end up with 3x minus 4 and 3x plus 4. And then we look for those matching brackets that we can cancel out. We end up with x plus 3 over 3x plus 4. Now when we're adding fractions, which we're doing in the next two questions, remember adding fractions, whether they have algebra or not in them, we need a common denominator. So we're going to make both of these into 28. So we've multiplied the first fraction by 7 and the second fraction by 4. That gives us, when we multiply 7 by the top, we get 7x plus 21. And on the top here we get 4x minus 20. Again, we keep our denominator the same and we collect like terms on the top. 11x plus 1 is our final answer. Looking at the next one, it works in the same way, we just need to make the denominator the same. Now obviously that's a little bit more difficult to do, but what we can do in this case is just put those two brackets beside each other. And then all we have to do is multiply the top left by the bottom right, which gives you 5x minus 10, and the top right by the bottom left, which is plus 8x plus 24. Collecting like terms gives you 13x plus 14 over, and then we don't need to expand our brackets unless it explicitly asks us to in the exam, so we can leave it like that. And if we wanted to expand our brackets, we would have ended up with an answer of x squared plus x minus 6. Now functions is another common higher topic that we can use. So looking at this very simply, f of x equals 2x squared plus 6 and g of x is 4x. It asks us to work out f of negative 3. Well, that just means we take function f and we sub in negative 3 for x. So we get 2 times negative 3 squared plus 6. Negative 3 squared is 9. 9 times 2 is 18. 18 plus 6 gives us 24. So that's all we need for that. Now the next two are your algebraic manipulation. We've got f of g of x. Now because g is on the inside, it means we're going to take g and we're going to substitute it in for x in f of x. So therefore we end up with 2 bracket 4x squared, because similar to we did in A, we just replaced it with minus 3. Here we're just replacing it with g of x plus 6. Now we're going to square our bracket first, which gives us 2 times 16x squared plus 6. And then that gives us 32x squared plus 6 as our final answer. The final question then, f minus 1 is your inverse function. So we have f of x equals 2x squared plus 6. Now what I like to think about is, if I ran through, what did I do with my x? The first thing I did was I squared it, then I multiplied by 2, and then I added 6. So the inverse function does the opposite of each of those processes in the reverse order. So instead of doing add 6, we're going to subtract 6. Instead of multiplying by 2, we're going to divide by 2. And then instead of squaring, we're going to find the square root. So therefore, f inverse of x is equal to, we start with our x. The first thing we did was we subtracted 6. We then divided the whole thing by 2. And we then found the entire square root. So that would be our inverse function in that case. Now we looked at proportion already, but we've also got things called proportion equations. Now remember we said proportion has direct proportion, as one increases, the other increases, so it's multiplied by a scale factor. For inversely proportional, as one increased, the other decreased, so that was we essentially divided one. So, but very simply, if you see directly proportional, it just means A, whatever A is equal to K, and then B being whatever second. Inversely proportional was A equals K divided by B. Sorry, I should say A, not L. So in the context of this question, we have M is directly proportional, so equals to K multiplied by the square of H. The square of H means H squared, so it's KH squared. We're then given some numbers, so we're going to sub those in. 48 is equal to K times 2 squared. 48 equals 4K, so K equals 12. So our equation then is M equals 12H squared. So I've just taken this original equation that I had, and I've subbed in my K. So this has moved to here, and I've just subbed in my 12. Then the follow-up question is often calculate one of the numbers when you're given the other one. So we're told that M is 108. So we get 108, subbing that into our formula that we just made, 12H squared. Dividing by 12 first, that's 9 is equal to H squared. So then H is equal to the square root of 9, which is equal to plus or minus 3. Now they'd probably just allow you to just write positive 3, but again, because it's algebra, it could be positive or negative 3. Similarly, in the next one, we've got inversely proportional to the cube root of t. So it's the cubed root of t. L is equal to K divided by the cubed root of t. Subbing in our values then that we're given, 10 is equal to K over the cubed root of 27. Cubed root of 27 is 3, so that's K over 3. So therefore, K is equal to 30. Subbing that in then to make my equation, I get L is equal to 30 over the cubed root of t. Now we can finish this by putting it into our next equation. So that's part 1 done. Part 2, we then have find L when t equals 64. So L is equal to 30 times the cubed root of 64. Now the cubed root of 64 is 4, so that's 30 divided by 4, which gives me an answer of either 15 over 2, or if you want as a decimal, 7.5. And that's what we would do in our proportional equations. So remember, directly proportional, K multiplied by the second thing, inversely proportional, K divided by whatever the second thing is. Now, triangles come up less often on paper 1 because there are only a finite number of values they can give you because of the exact trig values, which we'll cover in a few minutes. But they could ask Pythagoras, which they often do. Remember, with Pythagoras' theorem in a right angle triangle, the hypotenuse is always the longest side. So in this case, we're going to find the square root of, I always do the big number first, squared, then the small number squared. And because I know x is my hypotenuse, I know this needs to be bigger, so I'm just going to add those together. Then I can just work those out. That's 64 plus 36, which is the square root of 100, which is 10. So x equals 10. If I was finding a shorter side and I was given the hypotenuse, I would just have the hypotenuse squared minus the other given side squared and work it out from there. Again, similarly in this next one, we have a right angle triangle. There's our right angle. It says calculate the value of x. Now, in the same sense, we have opposite. So again, we're going to have to name this. This is the hypotenuse. This is the opposite. This is the adjacent. So we have cosine, because we're using the adjacent over the hypotenuse. Cosine of x is equal to the adjacent over the hypotenuse. Now, 7 over 14 is equal to a half. And one of the exact trig values you're supposed to know is cos of what is a half. So therefore we can see from that that x is just 60 degrees, because cos of 60 is a half. So that's one of the very few ways they could ask you that on a non-calculator paper, because it has to be one of those angles, 30, 45 or 60, unless they tell you some more information. Similarly with the sine and cosine rule, again they can only use 30, 60 and 45. Sine rule is the least frequent in the paper. Cosine and area are used much more frequently. So in this case, we have x over sine 60 is equal to 8 over sine 45. Now they could ask you this to make you do surds at the same time. So if we then cross multiply this, or sorry, if we bring this across and multiply, we get x is equal to 8 over root 2 over 2, which causes a bit of confusion here, multiplied by sine 60, which is root 3 over 2. So that looks really confusing. So what we're going to do instead is we're going to rewrite this as 8 divided by root 2 over 2 multiplied by root 3 over 2. Now when we divide, we then know we do keep change flip. So we do 8 times 2 over root 2 times root 3 over 2. That's 8 over 1. And now we can do some simplifying. These 2's will cancel and we'll end up with 8 root 3 over root 2. We don't like surds in the bottom, so we're going to rationalize that like we did earlier, and that will give us 8 root 6 over 2, which is 4 root 6. So you can see that could be quite a long question if they give you a complex one with the sine rule. Okay, cosine rule they tend to use a bit more frequently because cosine of 60 is quite a nice angle for us. Okay, so in this case we're using the cosine rule, so x squared is equal to 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 60. Now as we've already seen, the cosine of 60 is a half. So you then get 49 plus 100 minus 2 times 7 is 14. 14 times 10 is 140 times the cosine of 60, which is a half. So half of 140 is 70. Then we just go x squared is equal to, adding these together, that's 149. Take away 70 gives you 79. So x is equal to the square root of 79. And then they could ask you to simplify the surd or give you a nice value for that. But again, 79 can't be simplified. Finally, area of a triangle. We know that the area, when we're not given the perpendicular height, is a half AB sine C. So we can sub in our values. We get a half times 5 times 8 times the sine of 30. Again, they use the sine of 30 because it's a half. So therefore, 8 times 5 is 40, half that is 20, so it's 20 times a half, which is 10 centimeters squared. Okay, so it makes your life a little bit easier. They could put surds in there as well, but it's just worth being aware that those questions could come up and they expect you to know those exact values. Now, they're your exact trig values. Okay, there are lots of different ways to remember them, but I've just presented them there, so I recommend that if you don't know them, you want to just have a quick read through them, pause the video, take a minute, read through them, make whatever notes you need, and then when you're ready, just press play again and we'll do the next question. Now the other way they can ask you these is in isolation of triangles. They can just give you something like this and ask you to manipulate it. It tends to be one of the last questions on the paper, and it had been coming up every year, but in recent years it's not every single year it comes up. So if we substitute these values in, you get 5 over tan of 60 is the square root of 3 multiplied by 4 times the cosine of 30, that's 4 times cos of 30 is the square root of 3 over 2, plus 8 times the sine of 30, which is a half, times 2 times the sine of 45, which is 1. Now, if we multiply these together, we end up with 5 over root 3 times, I'm going to expand the 4 in first, 4 root 3 over 2, plus, on the other side we've got, sorry, that should be not 1 over 3, I did say a half, but I wrote a third, so apologies for that. It should be 8 times a half, which is then 4 times 2. So therefore on this side, you can see that these root 3's are going to cancel, and you then end up with 20 over 2 plus 4 times 2, which is 8. 20 over 2 simplifies to 10 plus 8, so that whole thing simplifies to 18. And often they'll say, show that this can be written as an integer or something, so they will cancel out. Okay, sometimes they won't, you'll be left with a surd, but there have been questions before where it just simplifies down to a whole number. Next topic is area of a circle. Okay, I haven't done all of the areas, but area of a circle is one that people make a mistake on. Now just be aware that this does appear on your formula sheet. It's in the top left hand corner. So the area of a circle is pi times the radius squared. In this case, this is the diameter, so the diameter is 8, so the radius is 4. So therefore all you need to do is pi times 4 squared, which is 16 pi. Circumference is pi times diameter, so therefore it's just 8 pi. And there's your two answers. The next one now is a sector. It's part of a circle. Now if you want to find the area, you're going to do the same thing. Pi times the radius squared, because the radius is 6, So radius equals 6, diameter equals 12. Okay. Now we don't have a full circle. We've got 120 degrees, but a full circle is 360 degrees. Now if we simplify that fraction, you'll see that that simplifies to 1/3. So what we have is 1/3 of a circle, and I like to do that bit on the side, so then it just makes it tidier over here. So now I've got 1/3 multiplied by 6 squared is 36 pi. And to find 1/3 of a number, you just divide by 3, so that's 12 pi is the area of that sector. The perimeter works in a very similar way. We're going to find this curved bit first, which again is 1/3 of the diameter, so 1/3 times pi times the diameter, which is 1/3 times 12 pi, which is 4 pi. Now the perimeter is all the way around the outside, so we've got 4 pi for the curved part, and then we've got this line and this line, both of which are 6. So it's 4 pi plus 12 to give you your final answer. And if you're asked to find the perimeter of a sector, it will usually be something pi plus an integer. Volumes, again, you can be asked volumes of prisms, cuboids, etc. I've put these ones on there just as a reminder. So with a cylinder, you're not given the formula, but just remember it's a circle, pi r squared, times the height. So therefore it's pi times 5 squared times 12. So that's 25 pi times 12. And 25 times 12 is 300 pi. A cone is very similar. Again, you're usually given the formula, but in case you're not, a cone is the same formula, pi times the radius squared times the height, and it's just 1/3 of that shape. So you've got 1/3 times pi times the radius squared, which is 4 squared, because remember this is the diameter, so it's 4 for the radius, times the height, which is 15. So 1/3 times 4 squared is 16, so we've got 1/3 times 16 pi times 15. Now, because of the commutative property, we can multiply these in any order we want. So I'm actually going to find 1/3 of the 15 instead and go 5 times 16 pi, which is easier for me to do, and that gives me 80 pi. Finally, a sphere, and you're always given the formula for this. So a sphere is 4/3 pi times the radius cubed, and a hemisphere is 2/3 pi r cubed. Just be careful about which formula they give you and which one you need, because sometimes they give you the one you don't need and you have to either half it or double it. So we're trying to find the volume of the sphere. So we get 4/3 times pi times 3 squared. That's 4/3 times pi times 9, and then 4/3 of 9 divided by the bottom times by the top. 9 divided by 3 is 3, times 4 is 12 pi. Okay, so our answer to that last one is 12 pi. And again, they're all centimeters cubed. So again, just remembering our units on those. Even with the pi there, it's still perfectly valid. Now, angle facts, there's lots of different ways they can ask these. This is just a reminder of the key facts. This is a straight line, and that equals 180. If you've got an x, these are vertically opposite. And that equals, they're equal. This is around a point. So at a point, or a full circle, is 360. In a triangle, that equals 180. And then in a four-sided shape, which is a quadrilateral, that equals 360. And just knowing those facts will help you quite a lot. There are other intricate facts that you need to know about kites, parallelograms, trapeziums, but those are the kind of basic ones you need to know. The other angle facts you need to be aware of is obviously in parallel lines. Now, the key thing to remember here, even if you can't remember the names of the rules, there are only two angles. There's a big one and a small one. So if I call the big one a capital B, all of the big angles, as in bigger than 90 degrees, are all the same size if those lines are parallel. And all of the small angles, so we'll call them L for little angles, all of the L's are the same. Now, there are certain rules. The first one is that this one and this one, so I think of it in two halves. So if I put a line through the middle here, those two green ones are in the same position. This one's in the bottom right of the top section, this one's in the bottom right. If they're in the same position, they are corresponding. And they are equal, because you can see they're both B's. The second one you could have is, let's use a different color. Let's say this L here, that's in the top right. And then the opposite of that is the bottom left. So it's in the opposite position. If they're in the opposite position, they're alternate angles. And you can see they're also equal. So opposite position. And then these ones were same position. The final one then are co-interior angles. And these tend to be the ones that people don't mix up. And they sum or add to 180. Now interior means inside, so it means that this inside angle here and this inside angle here. So the other thing to remember is that all the B's are the same, all the L's are the same, and B plus L is always equal to 180 because it's on a straight line. Okay, and that should allow you to work out any of the angles even if you can't remember the rules. One of the last things to do with angles is angles and polygons. Now a regular polygon just means all the sides and all the angles are the same. Irregular polygon means the sides and angles aren't the same. Okay, now to find in a regular polygon, you could be asked to find the interior or the exterior angle. I always start with the exterior angle, even if I'm asked for the interior, because it's always 360 degrees divided by n, the number of sides. So in this question, I've got 1, 2, 3, 4, 5, 6, 7, 8 sides. That's an octagon. 360 divided by 8 is 45 degrees. That means the exterior angle, which is here, is 45 degrees. That's exterior. So the interior angle then makes a straight line. So you do 180 minus 45, which is 135 degrees. Okay, so the interior is equal to 180 minus the exterior. Obviously in an irregular polygon they're not all the same, so these don't work. But the other thing you could have, which works for both, is the interior sum. That's all of them added up. Now that's going to be n minus 2, remember n is the number of sides, multiplied by 180. So in this case I've got 5 sides, 1, 2, 3, 4, 5, so I would do 5 minus 2 times 180, which is 3 times 180, which is 540. So therefore if I add up 1, 2, 3, 4, 5, they will all add up to give me 540 degrees. The same thing would work on my regular polygon. As my octagon's got 8 sides, I would have 8 minus 2 times 180, which is 6 times 180. Okay, so that's 600, 640, that's 1080 degrees. I could have also done that with the 135 that I had, so 135 times 8, which also gives me 1080, and that's all the angles added up. So again, that's all you need to know about angles and polygons, and it should help you answer any question they ask. Next one, you've got circle theorems, and it's very difficult to know what they're going to ask about circle theorems or what might come up. So just a general reminder of all the circle theorems. The first one, if you have this shape, just remember that this angle here on the outside is half of the angle in the middle, or the angle in the middle is double the angle on the outside. So the angle at the center is twice the angle of the circumference. In this case, we've got a triangle that goes through the center point. So because it goes through the center point, that means that's the diameter. That means this is always a right angle triangle. The next one, we've got a quadrilateral, a 4-sided shape. All 4 vertices are on the circumference. And what that means is the opposite angles add to make 180. And that's the same in both directions. In this shape, this it looks a bit like a bow tie. They call it angles in the same segment. This angle here and this angle here are equal, and this angle here, which we'll call y, and this angle here are equal. So those two top angles, those two bottom angles are equal. Moving to the bottom left, this is the only one that has a name. This is called the alternate segment theorem. If you've got a triangle and all three vertices are on the circumference, and then you've got a tangent and the tangent goes through one of the vertices, it's what we call the alternate segment theorem. And what that tells us is that this angle here, between the straight line and the straight line, angles don't include curved lines, so the straight line here and the straight line here, they're both equal. And equally this side, we'll call that y, is equal to this side, which is y. The next one, if you've got two tangents to a circle and they join here, so these are both tangents, this line is the same length as this line. So if you've got two tangents, those lines are exactly the same length from the point of intersection to that point they intersect at. Next one, if you've got a radius and a tangent, they will always meet at 90 degrees, which often is coupled with this one, because if I draw these radii here, you then have right angles, and then you've got a shape here you can work with a kite. And then finally, this isn't really a theorem, but it comes up quite a little bit, is when you've got this triangle where you've got a line from the center to the outside, line from the center to the outside. Well, these are both radii, which makes this an isosceles triangle all the time. So therefore, because that's isosceles, you know your two base angles are the same, and then you can just figure out what the other one is. Okay, so that's just circle theorems. Again, I'm not going to go into any of the questions in detail because the question could look completely different. It could be a simple one of work out the angle, or they could layer a few on top of each other. Next, we've got scatter diagrams. So statistical diagrams comes up quite a bit. So there's two things you could be asked. What does the correlation show? Correlation, we talk about, in this case, we're talking about a positive correlation. What that just means is as you look at the dots and move from left to right, are they going up or are they going down? Because they're going up, it's a positive correlation. If it was coming down, to be a negative correlation. The relationship is different, and what you have to do is talk about the context. Now, I've not put any titles on here intentionally, but whatever the context is, you're going to use this sentence starter, or this sentence structure, I should say. As x, and you're going to put in the name for x, increases, y, and then you're just going to make a decision here, increases or decreases. Now, in this question, the answer is increases, okay, because you can see it goes up because it's a positive correlation. So if this at the bottom said if the bottom was time and the top was, I don't know, melting level, as time increases, the level of melt increases, for example. Okay, so whatever those values are, you just sub in those words as x increases, and then if your graph goes up, y increases, or if it comes down, y decreases. Then it says use a line of best fit to estimate the value of y when x equals 4.5. Now, your line of best fit, and there's often a confusion here when it comes to science as well, your line of best fit here has to be a straight line. So you just get your ruler and go roughly through the middle of all the points. And you want kind of roughly the same number on either side of the line. There is a level of variability you're allowed to have. That tends to be close enough. And then it says, use your line of best fit to estimate the value of 4.5. Well, 4.5 is here. So we're going to come up to our graph, which is there. We're going to come across here, which gives us an answer of 19. So we're going to say y equals 19. Okay, so we just read from our graph, but it has to be based on your line of best fit. Even if your line of best fit is wrong, if you correctly read from it, you can still get a mark on that question. So just make sure you read accurately from your graph. The next statistical graph we're going to look at is commutative frequency curves. Now, commutative frequency means we're going to find the running total. So we're going to add these up as we go along, which is 4, 16, 32, and 40. Which means then we've now got our scale for our vertical axis and our scale for our horizontal axis, because that goes from 10 to 50. So we can just go 10, 20, 30, 40, and 50. And then vertically we can just go 10, 20, 30, and 40. Now we're going to plot our upper bounds, so the 20, 30, 40, and 50 with our commutative frequency. So 20 goes up to 4, which is there. 30 goes up to 16, which is just there. 40 goes up to 32. And 50 goes up to 40. Now, The level of tolerance you're allowed is half of one of those little boxes, so we need to be quite accurate with this. Now our graph then starts at 10 because 10 was our lowest mass, so we're going to put an X there. And then we're going to join these up using a smooth freehand curve. Okay. Now, obviously, while we would love this to work very, very perfectly every single time, if you're feeling nervous about it, just take a ruler out and join the dots very carefully. Again, making sure you go exactly through each of your dots. Okay, because again, the level of tolerance, that plus or minus half a tiny box, is based on the dots and the curve. Okay, so you get a mark for drawing that curve, so take the minute to do it. Next, we're asked to find the median and the interquartile range. Well, the median is the middle, so half of the people is 20. So we can come across at 20 and come down. And that gives us an answer of 33 for the median. So median is equal to 33. The lower quartile then is halfway between that 20 and the bottom, which is our 10. So again, we come over to our graph, we come down, and that would be 26. So the lower quartile is 26. And the upper quartile is halfway between 20 and 40, which is of course 30. Again, we come across to our graph, and this has worked out quite nicely for us. It lands exactly on some boxes for us, and that gives us an upper quartile of 39. Okay, because that lands on 39. So our median then is given, that's 33, and our interquartile range is our upper quartile, 39, minus our lower quartile, 26, which gives us 13. So our interquartile range is 13, which is essentially the gap here. That's your interquartile range. Okay, so remember, take your time with your graph so that it's fully accurate. Next one we're looking at is histograms. Now histogram is one that again is often there's a mistake on, which in this case we need to be very careful with. Histograms mean you need to find the frequency density. So to do that you're going to find the class width first. So that's how wide is each of these sections. So that's 10, 50, sorry, 25, 5, 10 and 15. And then we're going to find our frequency density. And our frequency density, remember, and this is the key thing for histograms, frequency density is equal to the frequency divided by the class width. So we're doing 18 divided by 10 is 1.8, 50 divided by 25 is 2, 20 divided by 5 is 4, 34 divided by 10 is 3.4, and then 12 divided by 15, okay, if we simplify that gives us 0.8. Now we draw our histogram. Now our histogram, remember, looks like a bar chart, but the bars are all different widths. So our scale on the bottom, that's 120, 130, 140, 150, 160, 170, 180, and then obviously 185 is right there on the end. And then going up, it goes up to as high as 4, so we can just go 1, 2, 3, 4, so that every little box is worth 0.1. So it makes the decimals really easy. So between 20 and 30 we go up to 1.8, which is here. So 120 to 130 is going to go there. Again, you'll use a pencil and a ruler to make this really nice and neat. That's our first box. Our next box between 20 and 130 and 155 goes up to 2. So therefore it's a little bit higher, but it comes much, much wider, all the way up to 155, which is there. And again, if you want to give it a little shade, just doing some diagonal lines, please feel free to. Don't spend too long shading it, it doesn't add any marks to it. 155 to 160 goes up to 4, so we've got a nice tall bar here in the middle. Which again allows you to do that. 160 to 170 goes to 3.4, so again 3.4 is here, 160 to 170 comes across and then comes down to the bottom. And I know I keep saying it, but you'll do this using a ruler, not freehand, so it's nice and neat. And then finally the last section goes up to 1.8, which is here. Apologies, a little bit lower. All the way over to the end of our graph. And that's our final histogram drawn. So that's our histogram drawn. It then asks us to estimate the number of people with a height between 140 and 165. Well, what we're going to do, and the key here is that the area is equal to the frequency. So therefore what we're going to do is we're going to draw those little barriers in. So that 140 there and 165 which is there. Okay, so here we can see that this goes, okay, so 140 to 155, that's a width of 15, multiplied by the height, which is 2, So that represents 30 people. So this section here is 30 people that I just did. This bar here, we need to use the whole thing, which we already know then, is 20, because that's 155 to 160. And here we can do the same thing, 5 times our height of 3.4. However, we can see that it runs exactly down the middle. It's half the box, and we know the whole box was 34, so half of that is 17. So therefore the number of people between those is 30 plus 20 plus 17, which gives you 67 people. Okay, so that's our histograms. Frequency trees. Again, frequency trees tend to be quite straightforward. They don't come up very often on the higher paper, but when they do, it's just making sure that we're confident with them. So it says there are 350 students in the sixth form. So 350 goes here at the start. 4/7 of the students are in year 12. Well, we've already looked at fractions. 4/7 of 350. We divide by the bottom and times by the top. So 350 divided by 7 is 50, times 4 is 200. So there's 200 year 12s, and that means there's 150 year 13s, because those two numbers add to make that number. It then says the ratio of male to female students in year 13 is 3 to 2. So in year 13, we've got 3 to 2, and we have 150 students in total, and that's male to female. So therefore 150 divided by 5 is 30. So therefore there's 90 males and 60 females. So 90 males and 60 females. And then it tells us in total there are 200 female students. Well, because we have 60 of them here, there must be 140 of them in here, which means that there must be 60 males in year 12. And that's our completed frequency tree. It then says a student is chosen at random. So that's out of all 350 students. So we should start, when we're working out our probabilities with the denominator. Work out the probability that they're male. Well, there's 60 males and 90 males, so that's 150 males. And you don't need to simplify that fraction. It makes life so much easier if you don't. Okay, there's no expectation when you do probability to simplify your fraction unless it specifically tells you to. Finally, the next one says a year 13 student is chosen at random. So in this case, the denominator is 150 because there's only 150 year 13s. Work out the probability that they're female. So that's 60 females out of 150. And again, no expectation to simplify that. Now the other type of tree diagram is a probability tree diagram. So those were frequency trees where we worked out frequencies, and we noticed that the branches was the names of each of the categories, and then the numbers were in circles. In this case, the categories or the outcomes are at the end of the branches, and we're going to put our probabilities on the branch. So it says a bag contains 7 red balls and 6 blue balls. Jeff takes a ball around and records its colour and puts it back. He then takes the second. So because he replaces it, that means these events are independent, which means every choice of red is the same and every choice of blue is the same. So the probability I choose red is 7 out of 13 in the whole bag. The probability of blue is 6 out of 13. And then we know that every one of these is exactly the same. 7 out of 13, 6 out of 13, 7 out of 13, 6 out of 13. Now it says work out the probability of selecting at least one red. So I want this one, or this one. This is the only one I don't want because that's 2 blues. To work out these probabilities, I multiply along the lines. So I do 7 over 13 times 7 over 13. That's 49 over 169. 42 over 169. And 42 over 169. And I'm going to add those together. So 49 over 169 plus 42 over 169 plus 42 over 169. Now we don't want... This is why we don't simplify them, because we can just add those together now because the denominators are all the same. So 42 plus 42 is 84. 84 plus 49 gives us 133. Okay, so we get 133 over 169 as our final answer. Now, the second box says a box contains 15 milk and 10 dark chocolates. Kieran chooses one at random and eats it. He then chooses a second at random and eats it. Now, because he's eating the sweets, he's not replacing them. So these are dependent events, which means the second branch or the second choice is going to be affected by the first choice. So in the first choice, we have 15 milk out of 20, and we have, 20 out of 25 because we add those together. And then dark is 10 out of 25. In the second branch, because I've chosen a milk, my denominators now are 24 because he's already eaten one of the sweets. If he's chosen a milk, then there's only 14 milk left, but there's still 10 dark chocolates left. In the same sense, dark, because he's chosen a dark, so we're restarting again. So he's back to having 25 chocolates in there. He chooses a dark, so therefore there are 15 milk left in there, and there are 9 dark. So the last one says, calculate the probability of choosing 2 of the same chocolates. Okay, now choosing 2 of the same chocolates, we want 2 milk or 2 dark. So that's this one or this one. So if we get 2 milk, we're going to do 15 times 14, which is 210, divided by 25 times 24, which is 600. Okay, and again, if you need to do that on the side, you can. Then 2 dark, same thing, 25 times 24, we already know is 600, and then 9 times 10 is 90. So 2 of the same chocolates then is 210 over 600 plus 90 over 600, which is 300 over 600. And that gives us our final answer. Now, coming up on our last couple of topics. So this one is estimating the mean. So this is the time in minutes the student took to complete a puzzle is recorded below. Work out an estimate for the mean time to complete that. Now, the reason we're estimating is because this 12, for example, means that 12 students took between 0 and 2 minutes, but we don't know how long they took. So to be fair, we're going to assume they were all in the middle. So the first thing we're going to find is our midpoints. So the midpoint of 0 and 2 is 1, 3, 5, 7, and 10. The next thing we're going to do is we're going to say, well, 12 students took 1 minute, so that's 12 minutes. 15 students took 3 minutes, so that's 45 minutes. 10 students took 5 minutes, is 50. Again, you can see the pattern, 9 times 7 is 63, and 10 times 4 is 40. Now I just like to call this the n times f, which is the midpoint times the frequency. Now we're going to add up all of those to give us the total amount of time taken. So if we add those, that's 0, carry my 1, that's 10, 15, 16, 20, that's 21. That's 210 minutes. So they took 210 minutes in total, everybody added together. Now in our group, our frequencies added together, if we add those up, that's 37, 46, that's 50 students. So we're dividing that by 50. So then if we simplify that, we get 21 divided by 5, which is 4.2 minutes as our final answer. Next, we look at the product rule, and that can come up in one of 2 ways. You could be given something like this, like a number of choices, or you could be given like a code to work out. Your number of choices, very simply, if you're trying to work out combinations from a menu, you've got 8 starters times 10 mains times 6 desserts, and you just multiply those together. Again, you can do this in any order, so 8 times 6 is 48, times 10 is 480 choices. Nice and easy. The other one you could have is where you're asked to make a code. So we're making 5-digit numbers, and they're even. 1, 2, 3, 4, 5. It's an even number, that means the last digit has to be a 0, 2, 4, 6, or 8. So we've got 5 choices. Again, these are the number of choices we have. So we've got 5 choices to that last number. And we want the number to be less than 60,000. Okay, so in that choice then, it has to be less than 6, so it's 5, 4, 3, 2, and 1. It can't be 0 because numbers can't start with 0, so you've got 5 numbers in there. And now, because we've got used up 2 choices, the rest of them, and we're not going to repeat them, that means we've got 8, 7, and 6 choices in each of those. So then, to find the total number of combinations, we're just going to multiply all of those. So 5 times 5 is 25, 25 times 6 is 150, and then 150, so we've got 150, 8 times 7 is 56, we times those by each other, that gives us 0, 0 carry my 3, that's 9, drop your 0, 0, 5, 7, that's 8,400 different combinations. And again, if you need to use your column method, do. Again, they tend not to make the numbers that big in non-calc, but again, they could. Then it says, instead, Phil is going to allow repeated digits. Work out how many more numbers he can make. Well, the first and last number don't change. There's still 5 choices there and 5 choices there. What changes is the middle options. Because you're allowed to repeat these, it just becomes 10 digits because 1 through 9 plus the 0. So therefore, you've got 10 choices in each one. So that's 10 times 10 is 100. Times 10 is 1,000, 1,000 times 5 is 5,000, times 5 is 25,000 different choices. Now it says how many more numbers can he make? So we just do 25,000 minus 8,400, which if we borrow and work from there, you get 0, 0, 6, and then 24 minus 8 gives you 16. So you get 16,600 extra codes he can make. Now, Venn diagrams is quite a popular topic that comes up nearly every year. So we've got 200 students in total. So I like to put that 200 up here just to remind myself, okay, that's how many I'm going for in total. Now, we've got the number of students who study history, art, and neither. Now, there's something wrong here because if I add those numbers up, I get 0, carry my 1, that's 11, 12, that's 7, carry 1, that's 270. But I've said there's only 200 students. But we expected that because actually those extra students, those 70, are the students that appear in the middle. So any extra you have, any excess you have above the total, if you have history, art, and neither, any excess go above that. Okay, we know 50 is neither, so they can go on the outside. And then it's just figuring out these art and history. Now, the total for history is 135. We've already put 70 in, so therefore there's 65 in this side. Similarly for art, there was 85 in total. We've already got 70, so there's 15 in there. And that's our final Venn diagram. Now, we can check our answer by adding all those up, which does give us 200. Now, similarly to frequency trees, it said a student is chosen at random, so that's one of the 200 students. Work out the probability they study both subjects. Again, just 70 out of 200. Because, again, we don't have any, we don't need to simplify that. It's just nice and easy. The next one says a student who chooses art is chosen at random. So the art students is 85 because it's the 15 plus the 70. What's the probability they also study history? So looking inside the art circle, there are 70 students who are also in the history circle. So it's 70 out of 85. So again, looking at that, building your denominators first and thinking, right, am I choosing all the students or am I choosing one of the sections is really important. And that's really prevalent in Venn diagrams. The other way you could be asked Venn diagrams is shading. Now there's lots of different ways to shading. What I'm going to do in this case is just show you each of the answers. Okay, so A is just everything inside of A, so it would just be that section there. B with a little apostrophe means B complement, so that means not B. Okay, so it's everything outside of B, so it's all the way around here, and even the intersection is included because it has to be outside of B, so we do not include the intersection. This next one, the intersection, this means both. So it's in both A and B. So it's just this section. This one, the U, is union, but means either or both. So it's in any of the circles. So it's all the way through there. And it's just about knowing how to read those. Now we can take this one step further. The next level is where we start combining these complements with these unions and intersections. So this means in A and not in B. So if it's inside A and it's not inside B, it's just this kind of crescent moon shape here. So that's in A and not inside B. The next one is the same thing as says in A or not inside B. That's different. So we're inside A, which is all of this here. And then not inside B also includes this. So this does include the intersection. Now that can often cause confusion. So what I like to do is describe it like this. If I clear all this off and just redo this one, I'm going to do A in green. So that's A. And then I'm going to do not B in red. So not B is everything outside of B. Okay, the intersection means both colors. So like we saw in the previous one, it's just this crescent moon shape. The union means any color. So therefore that's why it's everything but the kind of crescent moon for B. So the intersection means both, the union means any color. Finally, looking at these, again, like BIDMAS, our brackets work first. So we do A intersection B, which is just this middle part, and then the complement means not that. So it's everything but that center bit. So it's just everything outside of the intersection. And similarly with the next one, the union is both circles, so the complement, which is on the outside of both of them, it's just everything around the outside. And we get that. And that's what we would do for our shading. And that concludes all of our topics. Now, some final tips just to help you maximize your marks. Firstly, show all you're working out. You may receive partial marks even if you make a mistake. When you get to your answer, make sure you read the question again. Okay, you want to make sure that you've answered the question that was actually asked rather than just got to an answer and think you're finished. So reread it and see if your answer makes sense. Complete parts of questions, particularly in those long 3 to 5 mark questions. Complete anything that's like ratio, fraction, percentage, algebra part, so you can get some of the marks. Even if you don't know how to get any further, you might pick up 1, 2, 3 marks on there, which again will help you push towards that next grade boundary. Draw your diagrams in pencil. Okay, that's one of the most common mistakes that students make, because they'll make a mistake on the diagram and you just can't rub it out. Okay, so it's a good habit just to always draw in pencil. Attempt every question. Okay, there's no optional content in there, so you may guess something that helps you pick up some marks. Again, I don't recommend just sticking a random number in there. Look and go, okay, is there any algebra here? Is there a bracket I could expand? Is there a ratio I could share into? Is there a fraction I could simplify? What sort of stuff can I do that might get me some marks? And then annotate your diagrams. Okay, your working out on your diagrams will also be marked. Okay, so you need to be really, really clear that you can just get that and get some marks on that. Okay, wishing you all the best in your exam, and I hope it goes well for you.